Hey guys, this is Mr. H. Hey, I'm going to do a video on factoring binomials and polynomials. These show up on the Regents exam. Usually there's only one, excuse me, one question. But I want to give you guys an opportunity, if you see it, how you should do it. All right. So let me just jump into this. So on the screen is my iPad. Now here's the steps. And when you're factoring, one of the things that we're going to be using is menu 23. We used that when we were doing quadratics and simplifying radicals. We're going to use it for factoring as well. We need to find the prime factors because once we have those, we can find GCFs. We can also see if we can use difference of squares. All right. So first of all, menu 23 on all numbers, expand all of the exponents out, right? And then we're going to look for GCF, pull the GCF out, and then whatever is left, check to see if you can use the difference of perfect squares on that, and then you'll be done. Now, if you're not familiar with the difference of squares, let me explain what it is. Basically, it's just a rule that helps you factor when you have perfect squares and you're subtracting one from another. You're subtracting one perfect square from another perfect square. So in this case, we got a squared minus b squared. So basically what we're going to do is we're going to take the a's and we're going to put one in one parentheses, and then we're going to put one in another parentheses, and then we're going to do the same thing for the b squared. We're going to put one b here and one b here. Now, the only thing that you got to be careful of is you got to make sure that one is a minus and one is a plus. It doesn't matter which one, but one has to be minus, the other one has to be plus. Boom. That's the difference of perfect squares. This is true for variables. It's true for numbers. I'm going to show you how to use it. Now, I'm going to try to do 2 or 3 examples. So here's the first one. So it says factor 20x cubed minus 45x. First thing I'm going to do is just rewrite this. Now, my first step is I need the calculator. So I'm going to go get the calculator. And I am going to, where is it? Yes, I'm going to use menu 23. And then I'm going to put in 20. And then I'm going to do menu 23 again. And then I'm going to put in 45. And then so those are the prime factorizations. Now I'm going to use those and I'm going to expand these numbers out. So here we go. This is what we're doing. So here, this is going to be 20 is the same thing as 2 times 2 times 5. And then the x cubed is going to be x times x times x. So I'm expanding everything out because once I expand it out, it's easy for me to see the greatest common factors. And then I'm going to have minus. That minus is important. And then 45 is 3 times 3 times 5 and then times x. Now, what do I have in common? What numbers, what variables are in both terms? Well, there's a 5 here, there's a 5 here, there's an x here, there's an x here. So that means that's the greatest common factor. So I'm going to factor that out. It's going to be 5x, and I'm going to put parentheses. Now, when we do distribution, we get rid of parentheses. When we're factoring, we want to put parentheses in, and the more parentheses we have, the better. All right, so I added a parentheses. Now, let me show you what I'm going to do. I'm going to get rid of the 5x since I factored those out, those two numbers out. And then what I'm going to do is I'm just going to take this, what's left, and put it down here in the parentheses. I'm going to clean it up a little bit. So I'm going to take this part here. Actually, I'm going to take this part here and just move it closer. So now, if you can see this, what's left inside the parentheses is a perfect square. How do I know that? Because every number and every variable has an even number. So there's 2 2s, there's 2 x's, there's 2 3s. So those are perfect squares. Anytime you see an even number of a variable or a number, it's a perfect square, period. All right, so what I'm going to do is I'm going to use that rule we just did. So I'm going to write 5x here, and then I have 2 more parentheses that I'm adding. So I'm going to take a 2, put it here, and then I'm going to take a 2, put it here. I'm going to take an x, put it here, and I'm going to take an x and put it here. And then I'm going to do minus, plus, and then I'm going to take a 3, put it here. I'm going to take another 3 and put it here. Now, I'm done. So my final factor expression is going to be 5x times 2x minus 3 parentheses, 2x plus 3 parentheses. Factor. That's it. Now, if you want to check this, make this into a function, make this into a function, and then graph them. They should be identical. If they are not identical, that means you messed up. They should be identical. All right, let's go. I want to do another one. Maybe I can get 3 done. All right, so here we go. We got 5x cubed minus 80x. I'm going to menu 23. 5 is a prime number, so there's nothing else for me to do there. But I'm going to do menu 23 on 80. So that's going to be 80. Boom. And that's 2 to the 4th times 5. So now what I'm going to do is I'm going to expand this out. So this is going to be 5 times x times x times x minus, that minus is important, and then I'm going to expand this out. So it's going to be 2 times 2 times 2 times 2 times x. Oops, I forgot the 5. We got a 5 and then times x. Now we're looking for the GCF. Start with that. We got a 5 and an x. We got a 5 and an x. So we can factor that out. Boom. Put the parentheses. Now I'm just going to go. I'm going to get rid of the 5x since I pulled it out of both terms. And now what I have left goes inside the parentheses. Now, again, what's inside the parentheses is the difference of perfect squares. There's 2 x's, that's an even number. There's 4 2's, that's an even number. So that means that these are perfect squares. So now all I have to do is I'm going to rewrite it like this. And 1x goes here, 1x goes here. This is an x minus plus. Okay, 1 2 goes here, 1 2 goes here, 1 2 goes here. Why isn't it showing up? And then 1 2 goes here. Or we could say this pair of 2's goes here and this pair goes here. Either way, now all we got to do is simplify the number. So this is 2 times 2 is 4. 2 times 2 is 4. So here is our simplified factored completely expression. 5x times x minus 4 parentheses times x plus 4 parentheses. This is factored completely. Now, if you want to check it, graph it. Graph this as a function, graph this as a function. They should be identical. I'm going to do one more here. All right, this one, it says x cubed minus 36x. So all I'm going to do is, let me rewrite this really quickly. X to the 3rd power minus 36x. Now, I got to do menu 23 on 36. I know that's a perfect square, but I'm going to show you anyway. Menu 23, and then I'm going to put 36 in there. Boom, done. And now there you have it. Now what I'm going to do is I am going to expand these out. X times x times x. There's 3 x's multiplied together. Minus, we've got 2 times 2 times 3, and then we got an x. Now, we're looking for the GCF. First, always look for GCFs. Well, there's an x here, there's an x here, so I can factor out an x. Now, I'm going to put parentheses. Let me get rid of these 2 x's. Let me get rid of these 2 x's. Now, everything that's left goes inside the parentheses right here. Boom. Now, you should see this is the difference of perfect squares. There's 2 x's, there's 2 2's, there's 2 3's. So now, that means we're going to have this, bam, bam. We got an x out here. We're going to put one of the x's right here. The other x goes right here. Got a minus and a plus. One of the 2's goes here. One of the 2's goes here. One of the 3's goes over here. One of the 3's goes over here. We just split them. Right, so now we have x, simplify the numbers. 2 times 3 is 6. 2 times 3 is 6. So here is our completely factored expression. X times x minus 6 parentheses times x plus 6 parentheses. Now, again, you can make this into a function, and you can make this into a function and just graph them. They should be identical. That's it, guys. Let me go back through. Find, do menu 23 on any number that you have, then expand it out, look for the GCF, pull the GCF out, and then whatever remains, check it to see if it's something that can be further factored. Look for the difference of squares. If you have an even number of numbers or variables inside, then it's a perfect square. It has to also have a minus sign. Because look, if we had this x squared plus 9 squared, even though these are perfect squares, you can't do anything with it. You can't factor it because this is not a minus. All right, I hope this is helpful. Once you factor it out and find the GCF, it's a really kind of easy process to finish it. I hope this has been helpful. I'm going to stop and I'm going to post it.